Hello everyone. Today I would like to talk about a very simple and basic model about the stock price movement. Before we start, please pardon my English. I'm trying to improve it, and which is also one of the reasons I make this video. Another reason being, it's really a pleasure to share with you my understanding about what I have learned. So today this model is very basic, and I want to share about my intuitive understanding about this video. So here is a differential equation here, and what we are interested in is about the change in the stock price movement, which is ds. And here we would like to decompose it into two components, one being the trend factor, another component is the randomness factor. Firstly, let's look at the trend component. Imagine when the stock price moves from T1 to T2, and if there is no randomness in it, and there's only an inherent trend associated with this stock, the stock price should move from S1 to S2. So how do we quantify this change in S? So ideally we should have a factor that can describe the slope of this line. So here we have the mu as the slope coefficient, as well as the original stock price. So these two together, we will have the slope coefficient, and use this slope coefficient to times the change in time. We will have what we want here, the change in the stock price. So the reason for the S here, you can try to imagine the magnitude of change for a stock with initial price $1 as compared to the magnitude of change of a stock price with initial value of $100. The change will surely be different. So mu here is a percentage change, and the S here is the base value. So after we have identified the change in the trend component, we move to the randomness component. As we all know, the price movement of a stock is usually like this zigzag shape, and this is caused by the randomness light in it. So we also want to capture this feature. So here we introduce this stochastic differential equation where the dWt will add the randomness for us. The dWt here, it just follow a normal distribution with mean 0 and variance dt. So that means the change in this component, it follows a normal distribution, so it can be either to your left, either be a positive change or negative change. So there will be a randomness in it. And of course here, the sigma times S, this component will change according to different stocks. And the sigma here means the historical volatility of this stock, and the S means the initial stock price. And these two components together, we have the coefficient of change in the randomness. So imagine when the historical volatility has been very large, and the initial stock price is also very high, of course you will expect the randomness to be very high. So use this coefficient times a random change. We will have a random deviation from the trend line here. For example, in time point 2 here, without the randomness, you will expect the stock price to be at this point, right at here on the trend line. However, when we add this randomness, we will either move this point up or down to another place where it should be. So together when we add up these two components, one is the trend component and another is the randomness component, we will have what we really want to model, the real change in the stock price. So this is what I want to share. Thank you for watching it, and I will make further videos.